Okay, exam review for chapter 6-7. This is a system of equations. It's got three variables. It's got three equations. We need to choose a variable to eliminate. So choose two equations to eliminate a variable, and then choose two more equations to eliminate that same variable. So looking at this, notice a 3x here in this middle equation and a 3x here in the bottom equation. If this middle equation were multiplied by -1, it would become -3x minus 2y minus z is equal to +2. Bottom equation could stay the same, 3x plus 4y minus 2z equals 5. Now adding these two equations together, x is going to eliminate. -2y plus 4y is 2y. -z plus minus 2z is -3z. And 2 plus 5 is 7. So now we have an equation in terms of y and z. What we're going to need to do next is choose two more equations that eliminate the same variable. So here we eliminated x. We're going to have to eliminate x from another one of these two equations. So if we choose the top two, for example, this is a coefficient of 4, this is a coefficient of 3. The least common multiple is 12. So I'm going to multiply the top equation by -3, the bottom equation by +4. What that's going to do is give a coefficient of -12x here, a coefficient of +12x there. So those two equations are going to become -12x plus 9y plus 3z is equal to -30. That middle equation is 12x plus 8y plus 4z is equal to -8. Adding those together now, again x's cancel. 9y and 8y add to 17y. 3z plus 4z is 7z. That equals -38. Now we have two equations here in terms of the same variable, y and z. So now we can combine those. So I'm going to take this equation here and combine it with this one. 17y plus 7z equals -38. Now we need to eliminate a variable from here and solve for the remaining variable. So we can eliminate any variable here. We could, for example, try to eliminate z. So between a -3 and 7, the least common multiple is 21. So this would need to be multiplied by 7. This would need to be multiplied by 3. So this equation now becomes 14y minus 21z equals 49. 3 times 17, or 3 times 17y, 3 times 17 51y plus 21z, and 3 times -38 is -114. So the z's cancel when we add these together. 51y plus 14y is 65y. Z's gone, and 49 minus 114, that's -65. Divide both sides by 65 to get y equals -1. So now, moving backwards through this, plug y into one of these equations in terms of y and z. So I'm going to choose this equation here. So that's going to be 2 times negative 1 minus 3z equals 7. 2 times negative 1 is negative 2. Add that to 7 to get negative 3z equals 9. So z equals negative 3. So now we know z and we know y. So you can plug that into one of the original equations now to find x. So bottom equation, for example, 3x plus 4y minus 2z equals 5. Now 4 times negative 1 is negative 4, negative 4, and then negative 2 times negative 3 is 6, negative 4 plus 6 is 2. Subtract 2 from 5 to get 3. So x equals 1. So your solution is to point 1, comma negative 1, comma negative 3. Alright, question 2. Same type of thing as a system of equations, 3 variables, 3 equations. So we approach it the same way. Notice right off the bat, right here we have a negative y and a positive y, so adding equation 1 to equation 2 would result in 3x, y's cancel, 5z plus 4z is 9z, negative 2 plus 2 is equal to 0. So if we multiplied this middle equation by negative 4, that's going to cancel with that positive 4y, so that's going to become negative 8x minus 4y minus 16z is equal to negative 8. We're going to get 2x plus 4y minus 2z equals positive 8. Add y's cancel, negative 6x minus 18z equals 0. So now we need to make a system of equations with these two new equations here. Multiply bottom equation by 2. So what we're left with is the statement 0 equals 0, which is true. There are no variables to solve for, so we can't solve for a unique solution, but there are infinitely many. There are infinitely many solutions, and now it says if there are infinitely many solutions, then state the solutions in terms of a parameter t. So we need to let z equal that parameter t. Now parameter just means that t can take on any real number, and if t can take on any real number, that means z can also equal any real number. Our task now is to define x and y in terms of t. So now that we know that z equals t, we can go back up into this equation here to find the value of x in terms of t. So if z is equal to t, then 9 times z is equal to 9 times t. So 3x plus 9t is equal to 0. Subtract 9t on both sides and you get 3x equals negative 9t. Divide by 3 and get x equals negative 3t. And now we go back up to one of the original equations. Top one, for example, we need to solve for y. So if x is negative 3t, we're going to have negative 3t minus y plus 5t equals negative 2. Negative 3t plus 5t, that's 2t, so negative y plus 2t equals negative 2. So rearranging this slightly and getting y by itself would give the equation y equals 2t plus 2. So that's the final variable we needed, y equals 2t plus 2. So those are the values of all three of the variables. Z equals t, x equals negative 3t, y equals 2t plus 2. So your solution, x is negative 3t, y is 2t plus 2, z is equal to t. Okay, a little bit of a more simple system of equations to solve. It's got only two variables. So I'm going to try to eliminate the y variable. Between a negative 2 and positive 3, these come to multiple as 6. So I'm going to multiply this by 3, multiply that by 2. So we get the equation 24x minus 6y equals 15. Here we have negative 24x plus 6y is equal to 14. Now, the variables cancel, so there's a 0. And the statement is 0 is equal to 29. It's not a true statement. There aren't any variables to solve for anymore. This is an example of a system of equations with no solutions. Question 4. This is a system of nonlinear equations. This is a parabola. This is a linear function. So there are a number of ways we could solve this. For example, this bottom equation could be rearranged and solved for x. So this bottom equation could be written as x equals y minus 3 So if this x equals y minus 3, this x here equals y minus 3. So y minus 3 can be substituted in for that x. So instead of x squared, it's y minus 3 squared plus y equals 9. Y minus 3 squared is y squared minus 6y plus 9. And then we have the plus y equals 9. Subtract 9 on both sides. So you have y squared minus 5y is equal to 0. Factor out a y and get y minus 5 is equal to 0. So y is equal to 0 and y is equal to 5. Now these are two distinct y values, which means there's going to be two x values paired up with these y values. So to find the value of x, we place the values of y in here. So if y is equal to 0, then 0 minus 3 is negative 3, so x equals negative 3. If y is equal to 5, then 5 minus 3 is 2, so x equals 2. So two solutions are negative 3 comma 0 or 2 comma 5.
Okay, partial fraction decomposition. This comes from chapter 6, section 4, I think, 6.4. There was a lot to that section. You had to remember the different cases of what the form of the partial fraction looked like. And the form depended on what the denominator looked like in factored form, and that's important. On both of these examples, the denominators are already in factored form. That might not be the case on the test. So you have to make sure that the denominators are factored. So anyway, in part A, the factors are both linear and they're both unique or distinct. So in that case, the form of the partial fraction is A and B. We have an A and a B piece, and then the factors form the denominators. And before I get into solving this, I just want to show you how that differs here on part B. The factors are both linear, but the difference is this x minus 2 is repeated. So the forms of the fraction, the partial fraction, can be a little bit different. You have an A for this piece right here, but because there's two of these, we're going to have a B and a C. And over here, the A, that's going to be with the x minus 1. And then with the repeated linear factor, since it's repeated twice, you have x minus 2 and x minus 2 squared. So these are the forms of the partial fractions. Now up here on part A, after you make the form of the partial fractions, you multiply each side of the equation by the lowest common denominator. In this case, it's x minus 5, x plus 2, something over here. So that cancels out the denominator, and you're left with 7x plus 7. Now when the LCD distributes to that term, the x minus 5s would cancel, and so you're left with a times x plus 2, and then when it distributes here, the x plus 2 would cancel, so b multiplies x minus 5. Now you have to keep in mind what it is we're solving for. We're not solving for x, we're solving for the values of a and b, so it doesn't really matter what x equals. We can let x now equal whatever we want. The way this was presented in the discussion was to choose convenient values of x that would make either this a term disappear or this b term disappear. For example, if you plug in a negative 2 right here for x, negative 2 plus 2 is 0. 0 times a is 0, so the a would disappear. So I'm going to let x equal negative 2 for my first convenient value of x. Plug in a negative 2 for all the x's. So if you plug in a negative 2 right here for this x, that's negative 14 plus 7, which makes negative 7. Now the negative 2 in place of this x causes this term to disappear. Negative 2 minus 5 is negative 7. Negative 7 times b is negative 7b. If you divide by negative 7 on both sides, you get a value of b where b equals 1. Now, there's another convenient value we can choose here. If I've allowed x to equal 5, then 5 minus 5 is 0, so I'm also going to let x equal 5. 7 times 5 is 35, plus 7 is 42. Now over here, 5 plus 2 is 7. 7 times a is 7a. And then the 5 on this side, 5 minus 5 is 0, 0 times b is 0, so that term will disappear. Divide by 7 on both sides, so you get that a equals 6. So now that we have the values of a and b, we can finish the forms of the partial fraction. Instead of a over x minus 5, it's 6 over x minus 5 plus 1 over x plus 2. Now part B, we already have the form of the partial fraction set up. So the same first step as what we did on part A, we're going to multiply each side of the equation by the LCD. So on this side, x cancels out the denominator. Now the LCD has to multiply each of these pieces. So when this LCD multiplies all the way over to this first fraction, the x minus 1 here and the x minus 1 there will cancel. So a multiplies x minus 2 squared. Now when the LCD multiplies to the b term, this single x minus 2 on the denominator here would cancel with one of these x minus 2's. So you have one of the x minus 2's times an x minus 1 that multiplies the b. So it's plus b times x minus 1 times x minus 2. Now when the LCD multiplies in the c term, the x plus 2 squared cancels with the x plus 2 squared. So c multiplies x minus 1. Now we do a similar thing that we did on part A. We have to choose some convenient values of x that would make some of these terms disappear. First one that comes in my mind right now is let x equal 2. Just taking a look at this value right here, 2 minus 2 would be 0, so this term would disappear in that case. So if x equals 2, then right here, 2 squared is 4 times 4 is 16. The a piece of this equation would disappear. And so would the b part, because here if x is 2, 2 minus 2 is 0. 0 times the rest of these values will still be 0, so the b disappears. And over here, 2 minus 1 is 1. 1 times c is c. So right off the bat, we get the c is equal to 16. Now another convenient value we can choose is let x equal 1. If you take a look right here, 1 minus 1 is 0, so the c term disappears. And then over here for b, 1 minus 1 is 0. 0 times b times x minus 2, that disappears to 0. So over here on the left side, if x equals 1, 1 squared is 1 times 4 is 4. And then over here, 1 minus 2 is negative 1, but negative 1 squared is 1. 1 times a is a. So a equals 4. Now, this next part, you have to get a little creative. We've used the only two convenient values, quote unquote, of x that would make these terms disappear. Now, remember what I said a little bit earlier, it doesn't really matter what x equals because we're solving for a, b, and c, so you can really let x equal whatever you want. So I'm going to let x now just equal a random number. I'm going to choose 0, but I'm also going to let a and c take on their known values. I'm going to let c equal 16, and I'm going to let a equal 4. If you plug in a 0 for x, a 16 for a, and a 4 for a rather, and a 16 for c, then the only unknown in this whole equation would be b, and that's what we're solving for. So if x is 0, 0 squared is 0 times 4 is 0, so the left side of the equation is 0. Now remember, a was 4, x was 0, 0 minus 2 is negative 2 squared is 4, 4 times 4 is 16. And we don't know what b is, but x is 0, 0 minus 1 is negative 1, 0 minus 2 is negative 2, negative 2 times negative 1 is 2, 2 times b is 2b. And then over here, if c is equal to 16, and x is equal to 0, 0 minus 1 is negative 1, negative 1 times 16, negative 16. So those cancel, 0 is equal to 2b, and b is equal to 0. So we have the three values that we need. Now we can finish the partial fractions. We have 4 over x minus 1. Now, technically, since b is equal to 0, you could have a 0 over x minus 2, but 0 divided by anything is still 0, so you don't really need that middle piece. And then c is equal to 16, so 16 over x minus 2 squared. Now, question 6, this is just more practice with row operations. I've already given you the row operations to perform. If you were doing Gaussian elimination to reduce a matrix to row echelon form, you'd have to come up with the row operations on your own. But this is just for practice. We have negative 3 times row 1 plus row 2, and that's going to equal row 2. So let's do that one first. So negative 3 times this 1 is negative 3. Negative 3 plus negative 1 is negative 4. Then move over to the next column here. Negative 3 times negative 4 is 12. But 12 plus negative 6 is 6. And then move over to here. Negative 3 times this 3 is negative 9. Negative 9 plus negative 6 is negative 15. We move over to here. Negative 7 times negative 3 is 21. 21 plus 8 is 29. So that's the row operation that affects row 2. Now there's another one here that's going to affect row 3. We have 2 times row 1 plus row 3 equals row 3. So now 2 times row 1 is 2. 2 plus negative 7 is negative 5. 2 times row 1 here is negative 8. Negative 8 plus negative 5 is negative 13. 2 times row 1 here is 6. 6 plus 6 is 12. And then 2 times row 1 here is negative 14. Negative 14 plus 8 is negative 6. Row 1 stays the same. And that would be the resulting matrix. This line right here, some textbooks in an augmented matrix put a line right here just to show where the equal sign would be. Since these are coefficients of variables, this is where the equal sign would be, and these are the numbers after the equal sign. So that line in the middle really doesn't mean much.
Okay, multiplying two matrices. First we need to check that the multiplication is possible. This is a 2 by 3 matrix. It has 2 rows, 3 columns, so 2 by 3. This has 3 rows and 2 columns, so it's a 3
by 2. The inner dimensions tell you they have to match, so this multiplication is possible. The outer dimensions, 2 and a 2, are what this is going to result in. So it's going to result in a 2 by 2 matrix with 4 entries. This entry here comes from the first row, first column. So first row here, first column right here. So 3 times negative 1 is negative 3. Negative 8 times 8 is minus 64. And then negative 5 times negative 7 is positive 35. Now this entry here is second row, first column. So second row, first column here. 6 times negative 6, or negative 1 is negative 6. 6 times 8 is 48, and then 7 times negative 7 is negative 49. This entry here is the first row, second column. First row, second column here. So 3 times 10 is 30. Negative 8 times 3 is negative 24. And then negative 5 times 7 is negative 35. This is second row, second column here. Second row, second column. 6 times 10 is 60. 6 times 8, or 3 is 18, and then 7 times 7 is 49. So simplifying those numbers, as best you can without a calculator, I know it's tough. We're going to have negative 32, negative 7, negative 29, and 127. Question 8, find the inverse of a 2 by 2 matrix. So the formula is, given a matrix A, B, C, D, the inverse is 1 over AD minus BC, and that's a scalar multiplier in front of a matrix where you switch A and D and change the sign of B and C. So on this one, we need to find 1 over AD minus BC. So 1 over, now this is AD right here, that's 6, and we minus, this is B and C, so we minus negative 1. And then we switch the place of A and D here, so negative 2, negative 3, and then change the sign, change that to plus, change that to minus. So 1, negative 1. 6 minus negative 1 is 7, so it's 1/7 times the matrix. Negative 2, 1, negative 1. Negative 3. Solve the system of linear equations using matrix algebra. Matrix algebra means we have to set up a matrix equation, find the inverse of the coefficient matrix, and then multiply that on either side. So the matrix equation, these form the coefficients of the variables form the coefficient matrix. So the matrix is negative 3, negative 1, 1, negative 2. Now we have to have a variable matrix, and it equals this column 1 and 12. So what we're solving for is x and y. We need to get this xy matrix by itself. So we need to cancel or in some way undo this matrix in front of the xy matrix. So the only way to get rid of a matrix or to reduce it to 1 essentially is to multiply it by its inverse. So we need to find the inverse of this. But this matrix is simply the matrix from problem 8 here, and we've already found the inverse. This is A inverse. If we multiply by A inverse over here, that matrix is gone. We'd have to multiply it by the inverse to the left side here. So the matrix xy is equal to this inverse matrix we already found, 1/7. There's negative 2, negative 1, 1, negative 3, multiplied by this matrix, negative 1, 12. Now I would recommend that you multiply the two matrices together first and then times by the 1/7. So this is a 2 by 2 matrix, this is a 2 by 1 matrix. Multiplying a 2 by 2 to a 2 by 1 results in a 2 by 1. So it's just a single column with two entries. This entry comes from first row, And first column, 2 times negative 1 is 2. 1 times 12 is 12. Second row, negative 1 times negative 1 is 1. Negative 3 times 12 is minus 36. So this is 1/7 times 14 over negative 35. Now times by 1/7 and you get 2 negative 5, and that equals x and y. So x is 2, y is negative 5. So the solution is 2, negative 5. Number 10, evaluating a 2 by 2 determinant. The formula for a 2 by 2 determinant is AD minus BC. This is AD here, and then you subtract the BC product. So AD is 25 minus BC, which is negative 21. Minus a negative is the same as plus, so that's 46. 3 by 3 determinant is done so much a little more complicated. It's a little bit different. You need to expand across a row or down a column, and it doesn't matter which row or column you choose, but it is wisest to choose a row or a column that contains 0. So the top row, for example, contains a 0. So what you do is you consider each entry in that row that you've chosen. In this case, I've chosen the top row. That's what's called a cofactor. If you choose a cofactor, then you have to also find its minor. The minor is found by crossing out the column and the row that contains that cofactor. So you take the cofactor 8, multiply it by the discriminant of that minor matrix, 1, 3, 5, 9. And now we move on and continue with the next cofactor, find its minor. Now you have to follow a particular pattern when you're doing the 3 by 3 determinant. The pattern is plus, plus, minus, 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 or plus, minus, plus, depending on which row or column you're choosing. We chose the top row here, so I have to follow this pattern. We keep the first cofactor there, just whatever it is, positive. When we move over, though, we have to minus the next cofactor, which is negative 1. And now the minor, if we cross out the row and the column there, we're going to have a minor of 3, 8, 3, 9. I move over to the next one, and we add the next. This one tells us to add the next cofactor, but the next cofactor is 0. So it doesn't matter what its minor is. 0 times anything is 0. So this becomes 8 times the determinant 9 minus 15. And over here, negative or minus negative 1 is equal to plus 1, and this is 9 times 3, which is 27, minus 24. 27 minus 24. 9 minus 15 is negative 6. It's 8 times negative 6. And then 27 minus 24 is 3. 8 times negative 6 is negative 48. Plus 3 is negative 45. Question 12, you're meant to take this matrix equation and write it as the system of equations from which this matrix equation came. So this top row here, these are coefficients of an x, y, z variable respectively, and it would equal negative 21. So this first equation is x plus 4y minus 3z is equal to negative 21. This middle row here are the coefficients of the next equation, negative 5x minus 3y plus z is equal to 20. Bottom row are the coefficients of yet another equation, 8x plus y plus 5z is equal to negative 13. It says specifically, do not solve. So you just leave it. Question 13, using Cramer's rule to solve. Cramer's rule involves setting up a series of determinants and then dividing them to find your values of x and y, or z, however many variables you're looking for. So if it's 2 variables looking for, you need 3 determinants, d sub x, and d sub y. The determinant d is simply the determinant formed by the matrix of the coefficients of the variables. So this is negative 3, negative 1, 1, and negative 2. The determinant is going to be AD, negative 3 times negative 2, which is 6, minus negative 1, or minus the this cross product here, so that's minus negative 1, and that's 7. Now d sub x, the subscript says we're going to take out the coefficients of the variable x that were there, and the reason we're choosing x variable because it says d sub x. You replace those with these coefficients, negative 1 and 12, so the matrix becomes negative 1 and 12, and then it has the same y coefficient, negative 1, negative 2. Now to find that determinant, 8 times d is 2 minus 12 times negative 1 is negative 12. 2 minus negative 12 is 14. Now, the determinant d sub y means you don't consider the coefficients that were originally there for y. You replace them with those. The x column stays the same, so it's negative 3 or 1, but now the y column becomes negative 1 and 12. The determinant is negative 3 times 12, which is negative 36, minus 1 times negative 1, so that's negative 1. Those turn into plus. Negative 36 plus 1 is negative 35. Now Cramer's rule says that your x value is d sub x divided by d, which is 14 over 7, which is 2. The value for y is d sub y over d, which is negative 35 over 7. It's negative 5, so your solution is 2, comma negative 5. Question 14 says to solve the system of equations using an augmented matrix and then reducing it to row echelon form. So we first form the augmented matrix using coefficients. For the top row, we're going to have 1, negative 2, 1, and 1. For the middle row, be careful, there's a missing term, so you have to have that 0 there, and then 1, 2, 5. Bottom row are the coefficients here, 1, 1, 3, and 8. Now, the idea for row echelon form, the top row has to have a leading entry of 1, and then beneath it should be 0 and a 0. So we already have a 0 there, which is great. We need to get this to be a 0. You move over to the next column. Okay, in the second row here, this should be a 1. Right here should be a 1. We should get a 0 underneath that. Once we've accomplished that, we move over. We'll want to get this right here to be a 1. And that's the direction we need to head. So we need to describe a row operation that's going to take this 1 right here and reduce it to 0. So if we multiplied row 1 by negative 1, added it to row 3, and have that equal row 3. Negative 1 times row 1 is negative 1, plus 1 is 0. Negative 1 times row 1 here is 2. 2 plus 1 is 3. Here, negative 1 times row 1 is negative 1 plus 3 is 2. Negative 1 times row 1 here is negative 1 plus 8 is 7. That's all that's been affected so far. So we have a 1 and a 0 and a 0. This is already a 1, which is great. If it weren't a 1, you divide by whatever you need to make it equal 1. But since it's a 1, we need to get a 0 beneath it. So what we're going to do is describe a new row operation. If we multiplied row 2 by negative 3 and added it to row 3, that's going to turn that into a 0. So negative 3 times row 2 plus row 3, that's going to equal row 3. So negative 3 times this 0 plus that 0 is still 0, so we have a 0. Negative 3 times 1 is negative 3, plus 3 is 0. Negative 3 times 2 is negative 6, plus 2 is negative 4. Negative 3 times 5 is negative 15. Negative 15 plus 7 is negative 8. Now this bottom row has a 0, 0, and a negative 4 and a negative 8. What that means is negative 4 is a coefficient of z. There aren't any coefficients of x or y, so really from here we can start figuring out some of the variables. This row tells us that negative 4z equals negative 8, therefore z has to equal positive 2. Now if you go back up a step to this row is the equation y plus 2z is equal to 5, but if we know that z is equal to 2, 2 times 2 is 4. If you take 4 from 5, you get that y equals 1. Now, this top row is the equation x minus 2y plus z is equal to 1. If z is equal to 2 and y is equal to 1, that's become x minus 2 plus 2 is equal to 1. Negative 2 plus 2 reduces to 0, so x equals 1. Y equals 1 and z equals 2.
Okay. I'm going to stop this video and start a second video for the story problems.
Okay, this question here is from section 6.5, Systems of Inequalities. So what we're dealing with here, we have two inequalities that we're going to graph on one graph. And if you remember, inequalities have shaded areas, so what we have to figure out is where's the double shaded area. And then, so that's what the first part of the question is asking. Label the vertices with their coordinates. That means label the coordinates of where the two graphs intersect. So this top one here, I'm actually going to change this so that y is by itself. I'm going to subtract x squared on both sides. We're going to have y is less than or equal to negative x squared plus 5. So that's actually a parabola that's been moved up 5 units because of the plus 5. It's outside of the function. So that's a vertical transformation up 5 units. The minus sign flips the parabola upside down. This bottom inequality is linear. It's just in slope-intercept form, 2x plus 5. So starting with this parabola again, it's been shifted up 5 units. And then it's facing upside down. Plotting two other points here of the parabola. And really what should be happening here is you need to make a table of values so that this is a little more exact. We know one of the points already is 0, 5, and that was the vertex. If you let x equal 1, then 1 squared is 1. 1 times negative 1 is negative 1. Negative 1 plus 5 is 4. So the point 1, 4 right here is on the graph. That means using symmetry. You know that point across is on the graph. Now, you gotta be careful and remember that with inequality, sometimes the line is solid, sometimes it's dotted. And it has to do with inequality. Since there's a line underneath, it's an equal to inequality. It's a solid line. Okay, now we have to figure out where to shade. So I'm going to choose a test point. I'm going to choose a test point of 0, 0. So that means I'm going to plug a 0 in for y and a 0 right here for x. 0 squared is 0. 0 plus 5 is 5. And over here we would have a 0 on the left. So we have the statement 0 is less than or equal to 5. That's true. So we're going to be shading towards the test point, which means underneath. So shading right there. Now this second inequality is just a linear inequality in slope-intercept form. So the 5 is the line-intercept, 2 is the slope. So we'll go up to 5, and then up 2, and over 1. And we need to connect right there. And again, I use the solid line because it's y is greater than or equal to. There's an equal to. And now we need to see where to shade on this one. So I'm going to use the same test point of 0, 0. If I let y equals 0 and x equals 0, then 2 times 0 is 0. 0 plus 5 is 5. So we would have the statement here, 0 is greater than or equal to 5. 0 is not greater than or equal to 5, so that's not true. So on this linear inequality, I'm not going to shade towards the test point. I'm going to shade above the test point. This one's not easy to spot. Sometimes the double shaded area is a little bit easier to spot. But if you look at where both shades are, it's just this little teeny piece right in here. This would be known as the solution set. Okay? Now, the vertices, the coordinates of the vertices, that's where these two graphs are intersecting. Now we can kind of estimate here, and we have a point right here, and that one we know for sure is 0, 5. Not quite sure the location of this one. So what you do to find the intersection points is you have to change this into a system of equations instead of a system of inequalities. So I'm going to change this top one into y equals negative x squared plus 5, and y equals 2x plus 5. Now down here at the bottom, if y equals 2x plus 5 right here, then that means this y also equals 2x plus 5, so I'm going to make a substitution. Instead of y equals negative x squared plus 5, I'm going to say that 2x plus 5 equals negative x squared plus 5. This is a quadratic equation, so I'm going to get all the terms on one side and set it equal to 0 and then factor to solve it. So I'm going to add x squared to both sides, and I'm going to subtract 5. We have the equation x squared plus 2x is equal to 0. Factor out an x, and we have x times x plus 2 equals 0. So the solutions are x equals 0 and x equals negative 2. That's just what x equals. We have to also find the corresponding y values for each x value. So I'm going to use this equation right here. If this x is equal to 0, if you simplify over here, you're going to get the y is equal to 5, which we were expecting. This is the point 0, 5 right there that both graphs share in common. Now if x equals negative 2, you plug in a negative 2 right here. 2 times negative 2 is negative 4. Negative 4 plus 5 is 1. So y equals 1. So that's the point 0, 5. This is the point negative 2, 1. So you can see it's pretty close, but that's why we have to use algebra to find the intersection points and not just the graphs. Okay, this problem here is a linear programming problem. It's that appendix after chapter 5 that you had a few problems assigned to. Some of them are story problems. This one is a nice problem in the fact that you've already been given the objective function and you have the constraints already, so you don't have to try to figure those things out from a word problem. First step is to graph these constraints. X and y are both greater than or equal to 0. So that means your graph is here in the first quadrant. 2x plus y is less than or equal to 10. The y-intercept is 10. Count by 2 is 0. The x-intercept is 5. Then count by 2's. And then to figure out where to shade on this, you would use a test point. I'm going to choose a test point of 0, 0 of the origin. If you plug in a 0 for x, that turns into 0. A 0 for y turns that into 0. And you have the statement 0 is less than or equal to 10, which is true. So shading underneath that line towards the test point. Now for this one here, 2x plus 4y is less than or equal to 28. It's also a straight line. The x-intercept is 14. And the y-intercept is 7. And if you use a test point, same test point, 0, 0, you plug in a 0 here, that turns to 0. Plug in a 0 for y, that turns into 0. So you have 0 is less than or equal to 28. That's also true. So shading underneath that line as well. So the region that contains both shades is this region right here. It's called the feasible region. Now the feasible region is bounded, and each corner where lines intersect, or where a line intersects with an axis, that's called a vertex. We have vertices here. You've got to find the coordinates of all 4 of these vertices. That one, for example, is a 0.5 comma 0. That one obviously is 0 comma 0. That one is 0 comma 7. To find this one, since it's the intersection of two lines and not the intersection of a line with an axis, to figure out the intersection of two lines, you've got to solve a system of equations for those two lines. So we have 2x plus y is equal to 10, and we have 2x plus 4y is equal to 28. If you multiply the top one by a negative and add these together, you're going to get 3y equals 18, y equals 6. Now, you've got to go back and find x. If we take this top equation and take that 6 and plug it in there for y, you're going to get 2x plus 6 equals 10. Subtract 6 to get 2x equals 4. Divide by 2 to get x equals 2. So that intersection there is the point 2 comma 6. Now that you have the location of all four vertices, you plug their coordinates into the objective function, and the objective is to maximize the value of p. So you have to figure out the value of p at each of the vertices, 0, 0, 0, 7, 5, 0, and the value of p at 2 comma 6. So when you plug in 0 comma 0 to the objective function, you get 140, subtract 0 plus 3 times 0, which is 140. When you plug in a 0 comma 7, it's 140 minus 0 plus 3 times 7. That's 161. If you plug in a 5 0, it's 140 minus 5 plus 3 times 0, which is 135. Plug in a 2 comma 6, you get 140 subtract 2 plus 6, rather plus 3 times 6. This is 158 minus 2, which is 156. So the largest value of p is right here, 161. So the point at which that occurs is 0 comma 7. So the conclusion here is that 0 comma 7 maximizes the objective function. Okay, 17 and 18, both of these come from section 6.3. Right here, a chemist has 3 acid solutions. The question here is how many milliliters of each type of solution should be used. If there's 3 solutions and they're asking how many of each, that means we're going to have 3 different variables because we don't know how many of each. So we could say let x equal, we have to be extremely careful on how we define the variables. We can't just say x equals the 10% solution. That's not specific. What about the 10% solution? In this case, they're asking for how many milliliters of each, so we have to define our variables that way. X equals the number of milliliters of the 10% acid solution. Y is the number of milliliters of the 20% acid solution, and Z is equal to the number of milliliters of the 40% solution. Now we have to start gleaning out some information here. How many milliliters of each type should she use to make 100 milliliters total? So this chemist wants to have 100 milliliters, which is comprised of a combination of x, y, and z. So we know that x plus y plus z has to equal 100 milliliters. So there's the first equation. Now it says here that the 100 milliliters has to be 18% concentrated. So now we have to start talking about the concentration. So we're going to have 0.1, 10% of x, because the x solution is 10% concentrated. We're going to have 0.2 y plus 0.4 z, and here's where students make a very common but very costly mistake. A lot of students would want to just put a 0.18 right here, and that's incorrect, because if you look at how we've described this it's a concentration multiplied by an amount. It's 10% of the number of milliliters X. Over here it's 20% of the number of milliliters Y. So right now all we have is a concentration. It's 18%. But 18% of what? And it's 18% of the 100 milliliters. Now, this one right here, if she has to use 4 times as much of the 10% solution as the 40% solution. So she's using more of X than she is of Z. She's using 4 times as much of the 10%. So the problem with a phrase like this is students read it literally. They say, okay, there's a 4 times the 10%, so we have a 4x equals z, and they just read it too literally, and this is completely wrong. 4 times x doesn't equal z because x is already bigger than z in the first place, and if we multiply x by 4, now it's even bigger than z. If we want x to equal z, since x is already 4 times as big as z, you have to multiply the 4 over here by z to make it equal x. So that's the equation. X equals 4z. Now we have a system of equations. We have 3 equations, 3 variables. We need to solve this. Let's clean this up a little bit though, especially this middle equation. Not like in these decimals. So first of all, 0.18 times 100, that's just 18. And then if we multiply that middle equation by 10, that's going to get rid of the decimals. So let's go to the x plus y plus z equals 100, and then if we multiply that middle equation by 10, we get x plus 2y plus 4z equals 180. And then I'm going to subtract the 4z down here at this bottom equation, and we get x minus 4z equals 0. Now, we can solve this really using any method, not just methods in chapter 6, but we could also use methods in chapter 7. The matrices probably wouldn't be anybody's first choice, so I'm going to solve this using elimination. If you notice in this bottom equation, it's only in terms of x and z. Y is already done. So if we consider now these top 2 equations, if we eliminated y from these top 2 equations, that would give us an equation in terms of x and z that we could then combine with this equation in terms of x and z, and then solve for either one of those x or z. So I'm going to multiply the top equation by -2. That gives me -2x minus 2y minus 2z equals -200. Combine that with the middle equation of x plus 2y plus 4z equals 180. That's going to give negative x plus 2z is equal to -20. So what I was saying earlier is now both of these equations are in terms of the same 2 variables, x and z, so we can solve this as a system of equations now. Negative x plus 2z equals -20, and x minus 4z equals 0. The x's are gone. 2z minus 4z is -2z equals -20, so z equals 10. Now we were clear on how we define z is equal to z. Z is the number of milliliters of the 40% solution. So that means we're using 10 milliliters of the 10% solution. It says right here they're going to use 4 times as much of the 10% solution, so that means that has to be 40 milliliters of the 10% solution. And then if there's only 100 milliliters that are going to be used total, we've already used 50 milliliters here, so the amount of y has to be 50 milliliters. Okay, question 18. There's 3 types of gas, and the question is asking how many gallons, specifically wants how many gallons of regular, how many gallons right here of each type of gas were sold. Since there's 3 types and they're asking for the number of gallons for each, we need to know the 3 different variables. So x is the number of gallons of regular, y then would be the number of gallons of performance, and then z would be the number of gallons of premium. So define the variables, now we have to start setting some equations. Now it says right here, on a particular day, 6,500 gallons of gas were sold. It doesn't say what type of gas, it means it says total gas, 6,500 gallons. So total means you're going to add x plus y plus z, because that's the number of gallons of each type. If you add that all up, it's going to be 6,500 total. So now here it says the price, regular is $3 a gallon, performance is $3.20 a gallon, premium is $3.30. Talk about the revenue generator. The revenue generated for that day was $20,050. So the revenue just from regular gas was $3 multiplied by the number of gallons sold. The revenue generated from performance is $3.20 multiplied by the number of gallons sold. And from premium, it's $3.30 multiplied by the number of gallons sold premium. And according to this, the total revenue is $20,050. We have another one of these tricky phrases at the end here. 3 times as many gallons of regular as premium were sold. You don't want to read this literally and make a literal equation out of it. The number of gallons of regular is already 3 times greater than the number of gallons of premium. So in order to put an equal sign between x and z, they're not equal to each other. X is already 3 times larger than z. So in order for these to equal each other, you have to multiply z by 3 in order to make it equal x. So x is equal to 3z. So those are the 3 equations. Again, these decimals here aren't looking too good, so I'm going to multiply this middle equation by 10. So it becomes 30x plus 32y. This is the middle equation, plus 33z is equal to 200,500. Now this bottom equation, I'm going to minus the 3z over, and x minus 3z is equal to 0. It's a very similar situation as the problem above. You notice this bottom equation is only in terms of x and z. Y is missing. So I'm going to try to take the top 2 equations and eliminate the y variable. Now if you notice, there's a 32 coefficient in front of the y now in this middle equation. So if we were to take this top equation and multiply it by negative 32, that would allow us to eliminate y. So I'm going to multiply the top equation by negative 32. So it becomes negative 32x minus 32y minus 32z. And multiply 6,500 by negative 32, you get negative 208,000. So if we now add these two, the top 2 equations, we're going to get negative 2x plus z is equal to negative 7,500. If you now combine this equation right there, you have x minus 3z. And actually, what I'm going to do before I do that, I'm going to try to eliminate the x variable, so I'm going to have to go ahead and multiply this equation by 2. And then I'm going to bring it over here, so now it becomes 2x minus 6z equals 0. Add these together, we get negative 5z is equal to negative 7,500. Divide by negative 500z is equal to 1,500. So that's the number of gallons of premium. 1,500 gallons. Now I said there was 3 times as many gallons as regular, so if premium is 1,500 gallons, that means regular is 4,500 gallons. And there were only 6,500 gallons of gas sold that day. 1,500 and 4,500 is already 6,000, so that only leaves 500 gallons of performance.